Hello everyone, this is group 2 from Tyler, and the topic of our project is development and commercialization of fuel cell for automotive applications. The team members are Salju Paudel, he's the leader, Shubham Pokhrel, Sagar Shah, and I am Samir Sapkota. The, in this preliminary presentation, we'll be talking about the overview of our project, introduction of what we are going to do, little background about it. We'll talk about motivation, how we came on to this topic, then objectives of our project, and finally references and appendixes.
Hello everyone, I'm Sagar and I'll be going over the project overview. We are evaluating an electrochemical cell that produces electricity through redox reactions. Hydrogen fuel and oxygen is going through a proton exchange membrane, and the byproduct is an eco-friendly product, water. We'll be talking about the scope and development of fuel cells for automotive applications. We'll also see into energy, cost, and marketization of fuel cells. And we will be comparing fuel cells against traditional combustion engines on the stance of efficiency, sustainability, and cost effectiveness. Now, Sergio will go through introduction.
Thank you, Sagar. I will talk about the development of the fuel cells and the working mechanism of the fuel cells. First developed by the Sir William groups, the fuel cells has three basic components: a fuel electrode, also known as the anode, an oxygen electrode or cathode, and a proton electrolyte membrane. In the anode, the hydrogen molecule splits into the two proton ions and the two electrons. The proton ions passes through the proton exchange membrane to the cathode, whereas the electrons migrate from the external circuit to the cathode. At the cathode, the proton ions, the electrons, and the oxygen molecule combine to form water and releases some heat energy. Thus, in a fuel cell, one hydrogen molecule combined with half of the oxygen molecule to form water, perform some electrical work done, and this release of the sum of the heat energy. In a fuel cell, there is a possibility, or we can achieve the continued generation of the electricity and through the continued supply of the fuel, that is the hydrogen and the oxygen, to the fuel cell. In terms of the motivation behind this project has a possibility of having zero emission energy source with the reproducible hydrogen and oxygen fuel. The hydrogen and oxygen can be easily obtained from the environment and is reproducible. So it is easy to continue for the long run. It is a very viable alternative to the petroleum fuel and helps to meet the increasing global energy demand. This fuel cells device has a silent energy conversion with no any moving parts, which is better for the automotive application. Because of the lack of the dynamic components, the fuel efficiency in a fuel cell can be obtained up to 80%, whereas the internal combustion engine just had 25% fuel efficiency. The power amplification in a fuel cell can be easily obtained due to the modular structure of the fuel cells. Now I'll let Shubham talk about the rest of the presentation.
Thank you, Sergio. So today I'll be talking about the objectives of our project, and I'll also conclude the presentation. So the main objective of this project is to calculate the energy efficiency of fuel cell system, especially for the automotive application. For this, we'll do extensive energy analysis, also the energy efficiency analysis of the fuel cell system based on the equations and formulas provided on the research papers. Secondly, we'll also evaluate the cost effectiveness of the fuel cell systems for the motor vehicles. For this, we'll do a detailed cost analysis of the fuel cell system, and after looking at the results of the cost analysis, we'll determine how cost effective is the use of fuel cell system in motor vehicles. After that, we'll analyze the existing market scope and commercial challenges for the wider use of fuel cell system. We'll see what are the existing challenges and what are the future challenges that we might face for the fuel cell system, and we'll try to see if it can be available for a wider audience, for a wider range of consumers to use in the near future. And finally, we'll also compare the performance parameters of fuel cell system against that of the combustion engine. For this, we'll completely rely on the result of the research papers for obtaining the performance parameters of combustion engine, and we'll try to compare those two in terms of energy efficiency as well as in terms of cost effectiveness, and we'll try to determine which is a better use in the near future. Next slide. So these are just the references that we used for this presentation. Next slide. And in this appendix, you can see a difference in propulsion system of a fuel cell and that of a combustion engine. As you can see in the fuel cell propulsion, the fuel cell department is easily stackable. It is a modular design, so it is very easy to increase the power of fuel cell, and it also has a stationary part as compared to that of conventional propulsion system. Next slide. And this slide shows our tentative timeline for this project. We have tried to accommodate as much time as possible for the final energy and cost analysis as well as the final report, but this is just a tentative timeline, and if our group feels the need to change any schedule, we'll do accordingly. We'll try to redistribute our time and give as much time needed for each part possible. Thank you.